In this quick tutorial, we will discuss collecting Mitel SIP phone data for troubleshooting. Mitel phones can be integrated into different platforms. If they have the right configuration in the right environment, they function flawlessly. However, sometimes problems arise. Issues observed by a user are reported to their partner or Mitel support. With the steps to reproduce the problem and access to the same or similar environment, we can collect data from the phone and environment for troubleshooting. Sometimes the problem cannot be reproduced or the user cannot describe the scenario that caused the problem. This means we must collect data to identify the source of the problem. An important tool for troubleshooting is the phone's configuration file. You can access the configuration file from the phone's web user interface. The phone is routed to the configuration server to collect and access these configuration files. Enter the IP address of the phone into a browser. Enter the username admin and the password of 22222 or 5 twos. Navigate to troubleshooting. The local CFG and server CFG can be downloaded. The local CFG contains manual configuration performed by the user in the web user interface. The server CFG is the server-defined configuration. This means configuration performed in the web user interface overrides programming from the server CFG. With the configuration file, we need to collect a trace. You can collect a trace from a hub or by mirroring a switch port. A hub sends incoming packets to all ports, while a switch sends them only to the specific port connected to the destination. When using a hub, you can connect a PC running Wireshark to another port and collect all the data running through all the ports on that hub. With a switch, we must log into and collect the information by forwarding one port to another to receive information about the individual port. When forwarding port 2 to port 3, all the packets going to port 2 route through port 3 as well. With a monitoring device running a Wireshark, we can collect the trace. In modern networks, finding a hub can be difficult. With unmanaged switches or fully utilized switches, accessing the switch is not possible. When this is true, we can run a trace using port mirroring from the phone's Ethernet. The phone has 2 ports, the network port and the computer port. The computer port is used to connect a user's computer to the phone for network access, preventing the need for additional network cables to the switch. This allows you to configure the switch with port 4, mirroring to the computer port for troubleshooting. This offers 2 enablement options, through the configuration file or through the phone user interface. From the configuration file, through Ethernet port 1 mirroring, the configuration file enables port mirroring from the phone. To enable, on the SIP phone, press the Settings key, press Advanced, enter the administrator password, which by default is 22222 or 5 twos. Press Enter. Using the navigation wheel to scroll to the right, select Network, navigate down to Ethernet ports, press Select, navigate down to Port Mirror, navigate to the right and select Enable. Press the Save Soft key, press Quit. This trace method is recommended when you can reproduce the problem because the phone has limited memory for collecting traces. When problem scenarios are unknown, the trace may be too large for the phone's memory and information may be lost. If the user's phone is connected using Wi-Fi, the Ethernet port mirroring is not a viable collection method. If collecting the trace using hub, switch port mirror, or phone's Ethernet port mirror is not an option, phone's internal capture can be used to collect the trace. You can enable phone's internal capture from the web user interface. Select Capture. The default ports are set to 5060, which is used for signaling, to conserve the phone's internal memory. We can add any additional ports like RTP ports for SIP signaling. You must configure a timeout before you can start your capture. All the trace files are stored in the phone memory. When complete, return to the web user interface to stop the trace and download the capture file. You can enable the trace from the telephone user interface as well. Press Settings, press Advanced, enter the password 22222 or 52s, press Enter, navigate to Diagnostics, navigate down to Capture, press Select, set the trace timeout, press the Start Soft key. The phone starts to collect the traces, storing them internally. Press the Stop Soft key to end the capture. You must configure the capture server to be able to upload the capture for review. You can configure the capture server's network location from the telephone user interface, the web user interface, or through the configuration files. Once the files have been uploaded, they are automatically removed from the phone memory. Syslog is a self-generated message from the phone. It is used for debugging and troubleshooting. Without access to the code, the syslog message's meaning might be unclear. Collecting and reviewing syslog messages is our only option when TLS transport is used. There are two ways to enable the syslog: the web user interface or the configuration files. From the troubleshooting page of the web user interface, there are different modules that generate the syslog based on what we enable or disable. We must set a debug level to identify the depth of the syslog. The highest debug level is 65/535 to ensure we have all the available information. This does increase the load on the phone and may affect the phone's performance. This should only be enabled while troubleshooting. Software installed at the log IP address will collect and store the syslog messages. All of the values set in the web UI can be set using the configuration file too. The trace includes the syslog, making this the most common way to access this information. If we are collecting a phone side trace, it means we are using one of the following: a hub, a switch, the phone's port mirror, or the internal trace. With all these, we have SIP and syslog messages. We can send out any IP address, including a mock IP address, to collect the phone's system messages in the trace. Another way to collect the syslog is called log issue. When a problem is reproduced, the logs are collected from the phone. We have enabled the syslog module and level. Without an IP address, the phone generates and keeps the syslog internally using the phone's memory. After recreating the issue, most of the syslog can be collected through the log issue feature. From the phone interface, press the Settings key, press the Log Issue Soft key. The phone starts collecting the syslog in the memory. The syslog and additional information are all compressed into a tar file. If the network location is defined, the phone automatically sends the compressed tar file. You can collect the syslog from the web user interface. Click Troubleshooting. Click the Start button next to Log Issue. This allows technicians to collect log files without involving the user. Click Save As to collect the log files. Debug mode is another way to collect the syslog. Enabling debug mode from the phone generates all logs, including syslog, at the highest level with the most information. Press Settings, navigate to Diagnostics, navigate down to Log Upload, press the Select Soft key, press the Debug on Soft key. You must reproduce the problem. Once the problem has been reproduced, we need to collect the logs. Enabling this mode may have an impact on the phone's performance. Ensure you press Debug Off when you are done. The logs are compressed into tar files for download through the web user interface or the defined network path. At this point, we have collected configuration files, syslog, and trace. This information is used to review signaling, including information about calls not connecting, being rejected, or a feature not working. If audio quality is a problem, we can perform a phone trace to collect RTP information. If the audio is not encrypted, you need Wireshark to decode the codec used in the calls. If the RTP is not encrypted and the codec used is decoded by Wireshark, you should have the information needed to troubleshoot audio issues. We have the signaling and RTP packets. It shows the G711 codec that Wireshark can reproduce, replay the audio, and the unencrypted RTP messaging. Audio diagnostics is a phone feature used to collect audio-related logs. It collects the raw information about audio and an option to play back the audio. You can compare this to the user's experience. When RTP is not encrypted, we can collect both RTP and audio diagnostics. We can compare the audio raw information to determine if the bad audio was caused by the network or the phone. With encrypted audio, audio diagnostics is the only way to review the audio quality. When audio is encrypted, Wireshark cannot decode it, which means audio diagnostics is the only option to collect this information. From the phone, press the Settings key, navigate to Diagnostics. Navigate down to Audio Diagnostics, press the center of the navigation wheel or the Select Soft key, enter a timeout value between 1 and 5 minutes. Press the Start Soft key, the phone starts collecting raw audio information. Press the Close Soft key, press the Quit Soft key. To collect audio diagnostics, you need to make a call. Your audio source, handset, headset, or speakerphone must stay active for the duration of the data collection. With the audio diagnostics running, we cannot change the audio source. Navigate back to the Settings, Diagnostics, and Audio Diagnostics. Press the Select Soft key. Press the Stop Soft key to end the collection. Press the Close Soft key. Press Log Issue to collect the files from the phone. Select Diagnostics to collect the files from the web user interface. Next, to collect logs, click Save As. With configuration files, trace, syslog, RTP, and audio diagnostic logs, you have all the tools to troubleshoot your phone issues. External issues should be reported to the customer, while internal issues should be reported to Mitel. The Mitel support team will escalate the issue to our design team for resolution.